From Cape Canaveral Air Force Station in Florida, United Launch Alliance presents live Atlas V launch coverage. At Space Launch Complex 41, the Atlas V rocket is fueled and ready to launch the 8th GPS II-F mission for the United States Air Force.
Range go for launch. Roger, go for launch.
T-minus 3, 2, 1.
Atlas engine ignition.
Liftoff of the United Launch Alliance Delta IV Heavy rocket.
This is Atlas Mission Control at T-minus 4 minutes and holding. This planned 30-minute hold is designed to allow launch conductor Scott Barney and his team time to address any last-minute items. However, at this time, the team is not working any issues. Our 18-minute launch window opens at 1:21 p.m. Eastern Daylight Time. Good afternoon, and welcome to Mission Control in the Atlas Spaceflight Operations Center at Cape Canaveral Air Force Station. I'm Danielle Taylor, and I'll be your commentator for this afternoon's mission. Following liftoff, you'll hear the voice of Rob Gannon providing launch vehicle ascent data. I'll also be joined by Captain Kevin Pegalo from the Air Force's GPS Directorate. Due to the long duration of today's mission, our live coverage will conclude approximately 20 minutes after liftoff. As I mentioned earlier, today's mission is the 8th satellite in the GPS II-F series. This is the third GPS II-F launch on an Atlas V. ULA's Delta IV rocket has launched 5 II-F missions. GPS, or Global Positioning System, is a space-based radio positioning system, consisting of a minimum of a 24-satellite constellation, providing navigation and timing information to military and civilian users worldwide. The signals are so accurate that time can be measured to within a millionth of a second, velocity within a fraction of a mile per hour, and location to within 100 feet. Built by Boeing, the II-F series provides improved capabilities for military and civil users, and a new third civil signal, L5, for commercial aviation and safety of life applications. Recently, the launch team received a final weather briefing from the 45th Space Wing Weather Officer. The team was told that the weather is within the launch commit criteria for today's launch. The weather briefing provided the following information. The probability of violating the launch constraints is 30%. The ground winds are 6 knots out of the north, and the temperature is 80 degrees Fahrenheit. So we are proceeding toward liftoff with a planned T0 of 1:21 p.m. Eastern Daylight Time.
RFFTS LC.
Yes, RF, go ahead.
Roger, can you just verify that Davis system cameras are configured for launch?
Oh, verified.
Roger.
United Launch Alliance is using the Atlas V 401 configuration to launch the GPS II-F8 mission. This is the 50th Atlas V Evolved Expendable Launch Vehicle mission since the inaugural flight in 2002, and the 631st Atlas program launch overall. GPS II-F8 is ULA's 89th mission since formation in 2006. The Atlas V is produced in Decatur, Alabama and Harlingen, Texas. It is comprised of a common core booster powered by the RD-180 main engine and the Centaur second stage powered by the Aerojet Rocketdyne RL-10A engine. On October 13th, GPS II-F8 was encapsulated within a 4-meter diameter payload fairing, which protects it during ascent. The encapsulated payload fairing was mated to the Atlas V on October 20th. The Atlas V is prepared for launch at the Vertical Integration Facility, or the VIF. The VIF is located approximately 1/3 of a mile south of the launch pad. The fully integrated Atlas V was rolled to the pad yesterday. For those watching, you're looking at video taken yesterday at Space Launch Complex 41. Trackmobiles are used to transport the Atlas V and its mobile launch platform to the launch pad, a trip that takes about 30 minutes to complete. The Atlas V rocket stands 188 feet tall, or about 19 stories, and weighs more than 700,000 pounds fully fueled. At liftoff, the RD-180 engine produces more than 860,000 pounds of thrust to begin the rocket's flight. The animation you'll see after liftoff is referred to as Satellite Toolkit, or STK. STK uses real-time telemetry data during the flight to track the path of the launch vehicle beyond the range of ground-based cameras. While the team completes final preparations for launch, let's take a closer look at today's flight.
The following profile details the important events of this mission using approximate times.
Five, 4, 3. We have Atlas ignition. 2, 1, 0, and liftoff. We have liftoff of the Atlas 5.
The Atlas RD-180 main engine ignites to lift the vehicle away from the pad. Shortly after liftoff, Atlas begins its initial pitch, yaw, and roll maneuvers to attain the proper ascent profile and minimize aerodynamic load. The Atlas V reaches Mach 1, the speed of sound, at 78 seconds. At 90 seconds, the vehicle experiences maximum dynamic pressure. Approaching booster engine cutoff, the Atlas V is burning propellant at the rate of 1,600 pounds per second, traveling at approximately 16,000 miles per hour, and located 62 miles in altitude and 146 miles downrange. Booster engine cutoff occurs approximately 4 minutes after liftoff. 6 seconds after booster engine cutoff, the booster stage is jettisoned. The first Centaur main engine start takes place 10 seconds after booster separation. The payload fairing is jettisoned approximately 4.5 minutes into the flight. Cutoff of the Centaur main engine follows an approximately 13-minute burn. The mission now enters a nearly 3-hour coast phase. At just over 3 hours 18 minutes into the flight, the Centaur main engine is started for a second and final burn. This burn will last nearly 2 minutes. Following the second Centaur main engine cutoff, the mission enters a final coast phase. This coast phase will last nearly 5 minutes. At 3 hours 24 minutes, Centaur releases GPS II-F8 for the United States Air Force.
This is Atlas Mission Control at T-minus 4 minutes and holding. We remain in the planned 30-minute built-in hold as preparations for the launch continue. In a few moments, Launch Conductor Scott Barney will poll the team for their final go to resume the launch countdown. 27 engineers and managers are polled for system status and readiness to proceed with the launch. This is the final status check before launch for all Atlas vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The readiness poll includes hydraulics, pad water deluge system, electrical systems, pneumatics, propulsion systems, flight control, and propellants.
RC, verify solar radiation acceptable for launch.
Roger. Verified.
Roger. LC switch to ready position. All steps are complete prior to the status check.
At L-7 minutes, we'll listen in as launch conductor Scott Barney performs the final polling of the team.
Top check.
Read you loud and clear.
LC, RC1.
Go ahead, RC.
Launch window management plan through into window 1739 Zulu.
Roger.
Let's listen in as launch conductor Doug LeBeau performs the final polling of the team.
Status check to proceed with terminal count. Atlas systems, propulsion,
Go.
hydraulics,
Go.
pneumatics,
Go.
LO2,
Go.
water,
Go.
Centaur systems, propulsion,
Go.
pneumatics,
Go.
LO2,
Go.
LH2,
Go.
has gas,
Go.
electrical systems, airborne,
Go.
ground,
Go.
facility,
Go.
RFFTS,
Go.
flight control,
Go.
instrumentation,
Go.
comm,
Go.
timer,
Go.
GC cube,
Go.
umbilicals,
Go.
ECS,
Go.
redline monitor,
Go.
quality,
Go.
op safety manager,
Go.
ULA safety officer,
Go.
vehicle system engineer,
Go.
anomaly chief,
ACs go.
range coordinator,
Clear to proceed.
launch director,
MD, the launch vehicle is ready to launch.
mission director.
You have permission to launch.
Proceeding with the count. T0 is planned for 17:21 Zulu. Set count to start at 17:17 Zulu.
T0 set for 17:21:00 Zulu. Count will start at 17:17:00 Zulu.
TD, verify spacecraft configured for launch.
Spacecraft.
Polling is complete and the launch team has given the go for launch. The countdown will resume at T-4 minutes and approximately a minute and a half. From T-4 minutes until launch, you will be listening to launch conductor Doug LeBeau and his team performing the final steps in the countdown procedure. At T-3, the team will secure Atlas LO2 topping. At T-2, the team will transfer the Atlas and Centaur stages from ground facility power to internal battery power. At T-155, the team will command the launch sequencer to start, followed shortly by securing the Centaur LH2 and LO2 topping activity. At T-140, the team will command the flight control system to launch enable and arm the flight termination system. At T-40 seconds, the Atlas tanks will be verified at flight pressures, followed with verification of the Centaur tank pressures at T-30 seconds. A final status check of Atlas, Centaur, and GPS readiness is conducted at T-25 seconds. The RD-180 engine ignition occurs at T-3 seconds.
On my mark, the time will be T-minus 4 minutes and counting. 3, 2, 1, mark.
This is Atlas Mission Control at T-minus 4 minutes and counting. The countdown clock has resumed, and we are go for launch at 1:21 p.m. Eastern Daylight Time.
Three minutes.
Securing LO2 topping.
Atlas tanks to flight pressure.
$250. FTS internal.
T-minus 2 minutes, 30 seconds and counting. The countdown is on track as we proceed toward T0. Once the rocket lifts off, it will take approximately 78 seconds to reach Mach 1, or the speed of sound.
$159.
Vehicle internal.
$155.
Launch sequencer start.
$150.
Securing Centaur LH2.
Securing Centaur LO2.
$140.
FCS launch enable.
FTS armed.
T-minus 1 minute, 30 seconds and counting. The launch vehicle, payload, ground systems, and eastern range are go for launch.
120.
Orca's armed.
FCS count started.
$110.
Vent valves locked.
T-minus 1 minute and counting.
$40.
Stable at step 3.
$25.
Status check.
Go Atlas.
Go Centaur.
Go GPS.
20. 15.
This is Atlas Mission Control at T-minus 10, 9, 8, 7, 6, 5, 4, 3. We have ignition, 2, and liftoff of the United Launch Alliance Atlas V rocket carrying the 8th GPS II-F satellite for the United States Air Force. GPS provides worldwide positioning, navigation, and timing services for the military and civilian users. You are hearing the voice of Rob Gannon providing launch vehicle ascent data. Let's listen in for mission progress.
Good there. Full pitch yaw programs are in. Everything looking good. And we're continuing right down the center of the range track. 0.7 miles in altitude, 0.2 of a mile downrange, traveling at nearly 1,000 miles per hour. Engine continues to operate as expected. Flight control looks good. Rates are as expected. steady at 100% rated thrust. Everything is looking good. Roll program complete. Everything looking good. Continuing right down the center of the range track. Coming up on Mach 1. And the vehicle is now supersonic. Continuing to fly down the range track. Everything looks good. Engine is still operating as expected at 100% rated thrust. Flight control disturbances are good. We are now passing through max dynamic pressure. We have entered our second throttle phase. We are now operating the engine at 95% rated thrust, right as expected. And we are 10 miles in altitude, 5.9 miles downrange, traveling at nearly 2,000 miles per hour. Engine parameters look good. Vehicle is stable. Normal control on booster PU. And the vehicle is continuing to fly as expected. And we are now at 50% of our liftoff rate. Everything is looking good. Steering enabled. Normal transient for enabling steering. 95% rated thrust levels continue to look good. And fired the power valve, activating the reaction control system on Centaur. Pressure is coming up as expected. Everything looking good. Next event we expect to see is throttling down the main engine to 92% of rated thrust in approximately 20 seconds. We're now 34 miles in altitude, 55 miles downrange, traveling at over 5,000 miles per hour. And we've entered the next throttle segment, down at 92% rated thrust, right on time. Engine parameters looking good. Vehicle accelerating smoothly, good flight control. Rates are smooth. And the vehicle is now 25% of its liftoff weight. Next event we're looking for is entering our constant 5G throttle phase. In this phase, the RD-180 will throttle down to maintain a constant 5 Gs. And we have now started boost phase chill down on Centaur. Preparing the turbo pumps on Centaur for firing. Everything is looking good. And we've now entered the final phase. On the RD-180, filing a constant 4.6 Gs, coming up on booster engine cutoff. We have BECO, normal shutdown signatures. Coming up on staging, we have stage separation. Fired the retro rockets, pre-start and fuel, pre-start unlocks. We have ignition, full thrust. Our L10 is up and running normally, everything looking good. Smooth start transient, and we have fairing separation. Both brake wires indicate a successful fairing sep. And our L10 looks good. We've gone to fixed angles on the Centaur PU system. Engine operating parameters reacting as expected. Vehicle rates looking good. Everything looks normal. We've had our purge firings on the reaction control.
This is Atlas Mission Control at T+5 minutes. Rob Gannon has just confirmed payload fairing jettison, and all systems continue to operate nominally. The mission is in the first of 2 Centaur engine burns, as the Atlas V travels in a northeasterly direction up the east coast of the United States. Our next event, Centaur main engine cutoff, will occur about 12.5 minutes from now. I'm joined now by Captain Kevin Pegelow from the United States Air Force Global Positioning Systems Directorate. Captain, thanks for joining me.
Thanks, Danielle. It's an honor to be here today.
Captain, can you start by telling us about the current status of the GPS II-F program?
Yeah, the II-F program is near completion with the launch of the ACE satellite this afternoon. We currently have 7 space vehicles on orbit, meeting all their mission requirements. Additionally, there are 3 more vehicles that are in storage, and the last and 12th of the GPS II-F satellites is in the final stages of production at the Boeing facility and scheduled to launch by the end of 2016.
Great. And looking to the near term, when does the Air Force plan to launch GPS II-F9 using what launch vehicle?
Yeah, the II-F9 is tentatively scheduled to launch in March of 2015, and the launch vehicle for that mission will be a Delta IV rocket.
Great. Given the functionality of the legacy system on orbit long beyond its expected lifetime, how does that affect the need to launch GPS II-F satellites?
Yeah, the legacy GPS satellites have remained operational well past their design life due to the high-quality systems engineering and mission assurance practices of that program. Although this has diminished the urgency to launch the newer II-F satellites, the capability to launch them still is strong to continue to upgrade the constellation and maintain that high level of accuracy required for the global positioning system.
Captain Pegula, what made you decide to become an officer in the Air Force?
Well, I went to the University of Wisconsin-Madison.
Okay.
And so it was my sophomore year of college, and I was looking for opportunities of what I wanted to pursue in terms of a career.
Oh.
And so I was interested in the Air Force and ended up joining the ROTC program and then commissioned as an officer 2 years later, the same day I graduated college.
Wow. And can you tell our viewers a little bit about your background that got you the position you have today?
Yeah, well, I've actually had a very unique opportunity in the Air Force where I was given 2 career fields. The first as an intelligence officer.
Wow.
And the second as an acquisitions officer. So I did my first tour as an intel officer working with the B-52 bomber for 3 years. And then at the end of that I was given a list of assignments to transition to the acquisitions career field. And so on there I saw working with the Space and Missile Systems Center, and it sounded interesting to me, working with satellites and GPS, and so I selected that and actually was selected to come to Los Angeles Air Force Base to continue that mission as an acquisitions officer.
And how does your current position contribute to the GPS mission?
Yeah, as a member of the GPS User Equipment Division, we are responsible for the acquisition of GPS for military applications to support our mission to deliver sustained, reliable GPS to America's warfighter and our allies around the world. Specifically, I work on the integrations piece as part of the integrations team to integrate modern GPS into aircraft, ground vehicles, weapons, etc. And then lastly, I'm part of the team to work on new initialization of GPS receivers. We're establishing a new process to initialize receivers and get them out to the warfighter into the field in a more quick and efficient manner.
That sounds great. Captain Pegula, thank you so much for joining us this afternoon, and thank you for your service to our country.
Oh, thanks, Danielle. It's been a pleasure to be here.
This is Atlas Mission Control at T plus 8 minutes and 20 seconds. We are approaching the end of the first of 2 planned RL-10 Centaur engine burns. The Atlas V and GPS satellite are flying over the North Atlantic Ocean, south of Greenland, about midway between North America and Europe. Our next event, the first main engine cutoff, or MECO 1, is scheduled to take place about 9 minutes from now. While we wait for the next mission event, let's take a look at the video highlighting the important capabilities of the GPS Block II-F satellite.
The Global Positioning System is a marvel of the modern age. It consists of more than 30 GPS satellites circling the globe over 12,000 miles above us. In tightly controlled orbits, these U.S. Air Force satellites continuously transmit their signals to Earth. An extraordinary technology, GPS enables anyone with a GPS receiver to determine their precise location and the exact time anywhere in the world, usually within a meter and within a billionth of a second.
GPS is ubiquitous. It's everywhere. It's in our cars, it's in devices that you use to determine how far you've run or ridden your bicycle.
With billions of users and countless devices, it is easy to take GPS for granted. But it is the essential platform for innovations which enables us to do everyday things like buying gas at the pump and getting directions, and amazing things like tracking ice melts and saving lives in ways that were formerly impossible.
The beauty of the GPS system is that it's available for everyone. The cost of entry for any user is simply the cost of their receiver.
Boeing helped make GPS possible. It's been the U.S. Air Force's prime contractor on 4 major programs, replacing the initial group of satellites as their service lives were completed. Overall, Boeing has produced 2/3 of all GPS satellites, more than 40 in all.
Satellites are normally built in a low volume, perhaps 2 or 3 at most, and they're usually sit in one spot and resources are brought to the satellite.
Now, to ensure that GPS is available whenever it's needed, Boeing has changed how satellites are made. It's producing 12 new GPS satellites using a streamlined process based on its efficient and advanced airplane assembly line techniques.
Our goal is to have the highest quality,
These new satellites bring next-generation performance to the GPS constellation we all use every day. As a result, they are delivering new levels of accuracy to what is already a remarkably accurate system, and they are being built in a much more efficient way, ensuring that this essential technology is available when we need it.
Vehicle rate nice and smooth. First burn continues to operate normally. Vehicle parameters looking good. Center PU continuing to control near nominal MR. Everything looks good. Acceleration nice and smooth. Steady at around 0.7 of a G. Body rates are very close to 0. Everything looks good. It's passing through 12 minutes into the mission. Everything looking good. We're approximately 5 minutes to MECO 1. And we're now over 2,000 miles downrange, traveling at 15,500 miles per hour.
This is Atlas Mission Control at T plus 13 minutes. The GPS II-F8 mission lifted off from Space Launch Complex 41 here at Cape Canaveral Air Force Station at 1:21 p.m. Eastern. The mission is nearing the end of the first of 2 Centaur second stage engine burns. Our next event, MECO 1, is scheduled to take place a few minutes from now.
PU is controlling normally. Bottle and line temps on the reaction control system look good. Vehicle continues to fly normally. Approaching 14 minutes into the mission, everything looking good. And the vehicle is now approaching orbital conditions, continuing to burn normally. Our PU mass error is right down near 0 as expected. Everything is controlling normally. Main engine continues to operate normally. Locks and fuel pump discharge pressures look good. Chamber pressure looks good. Thermal conditioning firings continue to initiate as expected. Inlet conditions look good. Turbine inlet temp right as expected. 2 minutes to MECO 1. Body rates are nice and smooth. Vehicle's just over 3,000 miles downrange, traveling at over 19,000 miles per hour. Body rates are nice and smooth. PU control, right as expected. RCS loop temps look good, body rates look good. One minute to MECO 1. Engine operating normally, approaching MECO. "40 seconds to MECO 1. "30 seconds to MECO 1. Everything looking good.
Our next event, MECO 1, is scheduled to take place momentarily. Let's go back to Rob Gannon for the call.
PU is now in open loop control in preparation for MECO. Coming up on MECO. Cutoff. And normal shutdown signatures for MECO 1. Everything looking good.
This is Atlas Mission Control
is
at T plus 17 minutes 25 seconds. Rob Gannon just confirmed cutoff of the RL-10 engine. The mission has now entered an extended coast phase which will last about 3 hours. Following MECO 1, the mission trajectory changes to a southeasterly heading, flying over Eastern Europe, Turkey, and Saudi Arabia. It will continue in a south-southeasterly direction over the Indian Ocean. Following a short second burn of the RL-10 engine, the Centaur second stage will deliver the GPS II-F8 satellite to a semi-synchronous orbit over the Southern Ocean, north of Antarctica. Separation will take place about 3 hours and 24 minutes after liftoff. I'd like to thank Rob Gannon for his support of this afternoon's broadcast. I'd also like to thank Captain Pegalo for his support.
Thanks, Danielle. It's been a pleasure to be here today and to talk a little bit about the GPS mission with you.
Thank you. For more information on the Atlas V and this mission, please visit www.ulalaunch.com. Also, please join us in the conversation on Facebook, Twitter, and Instagram. We'll leave you now with another look at the liftoff of the Atlas V rocket carrying the GPS II-F mission for the United States Air Force. I'm Danielle Taylor, and on behalf of the entire launch team, thank you for joining us and have a wonderful afternoon. This is Atlas Mission Control at T-minus 10, 9, 8, 7, 6, 5, 4, 3. We have ignition, 2, and liftoff of the United Launch Alliance Atlas V rocket carrying the 8th GPS II-F satellite for the United States Air Force. GPS provides worldwide positioning, navigation, and timing services for the military and civilian users. You are hearing the voice of Rob Gannon providing launch vehicle ascent data. Let's listen in for mission progress.
Good there. Roll, pitch, yaw programs are in. Everything looking good. And we're continuing right down the center of the range track. 0.7 miles.